Hey everybody, it's Mrs. Dinkelman, and this is now Unit 10 where we're going to talk about the convergence or divergence of series. So if you remember, we talked with improper integrals about the definition for converging and diverging. So just kind of a recap, converging means that our limit is heading toward a finite number, and for diverging, we either get something infinite or we have something oscillating so we can't pin down a number. So it's divergent in that way. We're going to first talk about sequences because these pop up every once in a while. A sequence really is just a list of numbers that has some sort of pattern. When we get to series, that's the sigma notation, and that's when we start adding things together. So this first section is just about sequences. Again, just a list of numbers. So just to kind of recap, I know we've seen sequences before, but if we just try to write the first few terms, now we might talk about whether n here, like 3 to the n, does n start at 0 or does n start at 1? A lot of times we have to be specific about that, and that's why with our sigma notation, we generally like make a starting point so that we know. Let's just do, for the sake of having this definition here, start with n is 1. So for this one, we're going to get 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, 3 to the 5. Okay, so that's a sequence right there. And we probably should put a comma, dot, 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 because we're writing the first 5 terms, but this sequence could potentially go on forever. Then trying to kind of backwards. So here's the first, this one's 4 terms. How can I figure out what the nth term or the general term would be? So 3, 8, 5, or 3, 8, 13, 18, I was saying 5 because it looks to me like all of these have a difference of 5. That's one of the first things I look for. With that one, this is really linear then because that really is our slope. So I'm going to claim that a sub n. Now let's be careful here. My brain wants to start with 5n, 5 times n, plus 3. That would be if n starts with 0. So if we wanted n to start with 1, maybe we won't do it that way. We want n to start with 1. We could just perhaps subtract 5. So that would be 5n minus 2. Would that one work? If we start with n as 1, and let's just double check when n is 2, we get 8. Perfect. Okay, on the next one, we might try to do those differences again. So 3, oops, this one's not working, 7, 9. Now we could describe this one so far. We could say, oh, well, we keep adding the odds, but I wanted to do this one as an example to show you what happens if the second differences are the same. So the next time I take the differences, they're the same. That means there's going to be an n squared involved. So it looks to me like it literally is just n squared because 1 squared, 2 squared, 3 squared, 4 squared. But again, I wanted to have that second differences conversation with you. So lots of things to check out. Don't forget about having a base with an exponent being the n and all the different kinds of things when you're doing this homework assignment. So for the calculus part, we would say that a sequence is going to converge if we think about the last term, so that infinite term, if that last term is heading toward a number, L, then we're going to say that our sequence converges. For it to diverge, we're basically going to say that that last term is either infinite or we just can't pin it down. So all we really have to do for these is calculate the limit and look at that general term. So if we're heading toward infinity, I don't know why that doesn't want to write right now. Let's try again. For that n over n plus 1, and I'm just going to use what we know about if we have the same degree, we're just going to look at the ratio of the coefficients, so we get 1. So what this is really telling me is the last term is going to be something really close to 1. So this sequence is going to converge. Okay? Okay, so go ahead and get going, trying to write your first 5 terms, and then writing your general terms and finding whether a sequence will converge or diverge.